Hello, calculus fans. Okay, we're going to talk about related rates. And what we'll be doing now is measuring the rates of change of various quantities. And we're going to do this as they relate to each other. We've got a few different types of examples that we want to go over. One example is if there are two cars driving on perpendicular roads, we can measure the rate of change of the distance between them as the car's position change. We're going to have an example of one of these. Another common situation that we run into is if you have a spherical balloon, we can measure the rate at which the volume and the radius change as they relate to each other. And there's lots of other quantities we might measure. We'll see some examples of these as we go along. Now the book goes through a very nice step-by-step process for solving related rates problems. I'd like to outline this, and I'll rewrite it just a little bit, but I'd follow this pretty closely. You want to read the problem over carefully and draw a diagram. I think in any related rates problem, you're going to have a diagram. I just don't see any way of doing it without that. We're going to want to introduce some notation. Basically, we want to have a variable for every quantity that's a function of time. It could be a distance, it could be a volume, it could be all kinds of things that we're measuring that changes as time changes. You want to express the information that's given and the rate that we're looking for in terms of derivatives. And you should always have a list of all the variables and all the derivatives. I'll be doing this with various example problems that we'll be going through. We want to write down an equation that relates the quantities of the problem. Now, if necessary or if possible, we'd like to use some geometry of the problem to eliminate one of the variables via substitution. And then we'll use the chain rule to differentiate both sides of this equation with respect to time. And this is going to be very similar to what we did when we used implicit differentiation. And the last step will be to substitute our given information that's given in the problem into this equation that we get after taking a derivative, and we solve for the unknown rate. And we'll be going through some example problems to see how this works. Okay, that's all for now.